Welcome back. Let's start off with the iterative approach. That is, no recursion. If we want to run the function, let's say find factorial iterative 5, well, we can create a variable, let's say answer. And for now, this answer will be 1. And all we're going to do is do a for loop. We'll say let I equals 0. Or, in our case, to simplify things, let's start at 2. And I'm going to explain in a second why we want to start at 2. I'm going to say I is less than the number. And then we're going to increment I by 1. Now, why are we starting at 2? You might notice a shortcut here. 1 factorial is just 1. 2 factorial is 2 times 1, which is just 2. So these last 2 bits, if somebody says 1 factorial or 2 factorial, we can just simply return the number that they've entered because there's no real calculation that we need to do. So this is a little shortcut so we avoid extra loops by just saying that if the number that the user enters is, let's say, 2, so that is 2 is not greater than number 2. The way we have it now, if somebody enters find factorial iterative 2, we're going to return 1. But instead, we can just say maybe a simple conditional check saying that if number equals to 2, we'll just say that answer equals to 2. So that if I run this function and just say 2, I get 2. If I say 1, I get 1. And there's other checks that we can do, obviously. But for our case, this is good enough. Let's look at what we can do inside of here. Well, the way factorial works is to simply say answer is going to equal answer times I. So that if I click run here and let's do 5, I get 24, which is actually not the right answer because 5 times 4 is 20 times 3 is, well, clearly higher than 24. And that's because of a little mistake here. We want to make sure that this is equals because we want to include the number 5. So if I run this again, I get 120, which is the right answer. 5 times 4 is 20 times 3 is 60 times 2 is 120 times 1 is just 120. Perfect. So hopefully you got that answer correct. What about the recursive approach? In the recursive version, we'll just do a simple check saying if number is equal to 2, and we can do other checks as well, but that should be enough for now for us to create a base case. So if the number gets to 2, we'll just return 2. There's our base case. That's how we stop. Next, we're going to return our recursive version, which will simply be number times the function. And in this function, we're just going to say number minus 1. And that's the key here. We want to always get lower and lower until we hit the base case. So if I hit run here, let's do recursive this time. I'm going to move this up over here. And if I hit run, I also get 120. And this is a little hard to wrap your mind around. So you might want to copy this code and open up Google Chrome Developer Tools like I showed you and go step by step. But if we start with the number 5 here, well, does 5 equal 2? Nope. Then we'll say 5 times find factorial 4 should be our answer, just like the diagram that I showed you. And we keep going until we hit the base case of does the number equal 2? Now, one last bit. What do you think the time complexity of these two functions are? Well, one uses a for loop, with the loop being the number associated with it. And we're doing a bit of a shortcut here, so it's technically less than O of n, but because of our big O rules, this is still going to be O of n. The recursive function, if we look at this, we are looping how many times? Well, we're calling the function find factorial recursive the same number of times as the number itself. So this also becomes O of n. If you got this question, good job. It's a tough one. If you didn't, don't worry. We have another one coming up. I'll see you in the next one. Bye-bye.